0. And the range, what comes out, should be y values that are elements of what? 0 to infinity also. We're only going to get numbers that are positive out of this, and it is possible to get 0, but we're not ever going to get a negative out. Okay, I remember what I was thinking of something when I was putting this up here. Why is this not plus or minus 2, plus or minus 3? I thought when you did square root, you had to do plus or minus.
We're not putting it like ourselves. That is a given function.
That's right. This is given as square root of x. This is something that happens a lot when I always talk about my calculus classes because that's where I always have all the experiences of people like getting things confused. So just to be clear, the only time you do a plus or minus is if you start with an equation. Let's do this. If you start with that equation and you come in and you physically bring out the square root tool out of your toolbox and hit that thing with the square root on both sides. If you do that, if you initiate it, then you must do plus or minus, okay? But if it's presented to you like this, then there is no plus or minus. All right, good. So we have this idea of functions. We have inputs and outputs, domain and range. And now let's talk about the sine function. So I want to define a function where it has an input, and I want the output to be sine. Now, I don't want to put sine of x. And the reason I don't want to put sine of x is because the way we're defining sine is by trying to figure out the x and y coordinates, right, off that unit circle. So we're going to use t instead right now. But that's more like a dummy variable. So your input here is an angle, isn't it? Your input's an angle. And your output is the y coordinate off the unit circle for that angle. Yeah? T, f of t. 0. What's sine of 0? 0 degrees. Y coordinate. 0. Now, if I put 1 here, you're not going to be able to go to 1, all right? You're going to have to break your calculator out for that. So I'm going to give you an angle that you should know. What's, how about pi over 6? Sine of pi over 6. So 0, pi over 6, y coordinate? Which one? Half? Half? Next one. How about pi over 4? I'm kind of working my way around the circle right now. Root 2 over 2. Let's keep going. How about pi over 3? That's our next one. Root 3 over 2. And the next one would be straight up. That's pi over 2. 1. Right. Agreed? Okay. Let's keep going. It's kind of fun. What would be the next one if I'm marching around getting all the common angles? No. It was, wait, 3 pi over 3 pi over 6, 2 pi over 6, 3 pi over 6. 4 pi over 6 should be, that's 2 pi over 3, yes. Sorry, I need to march around. 2 pi over 3. Right? Yes or no? Y'all? Yes? Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, right? Which reduces to be. So what is the y coordinate here?
Negative root 3 over 2.
Y coordinate. We're up.
Oh, wait, that's right.
Positive root 3 over 2? T, f of t. All right, the next common one, 3 pi over 4, which is root 2 over 2 is the y coordinate. All right, where are we at now? 5 pi over 6, which is the y-coordinate there, which is a half.
And then pi is 0.
And then pi is 0. We're halfway around, right? We're halfway around. We started out at 0. As we started to move around, right, we started to get bigger, 0.5, then something that's like 0.707, then it went all the way up to 1, and then it started coming back down. So if we turn these into decimals, 0.5, I believe this is 0.707. Yes, and then this one is approximately, someone do that real quick, root 3 over 2. I don't know why, I should know that.
1.7 over 2.
It can't be bigger than, oh yeah, over 2. It can't be
1.7 over 2 will be
0.8? 0.8? 0.86? What is the next angle? If we're going around our common angles, we're at pi right now. What's the next one? 7 pi over 6 would be our next one. And that's going to give us the y-coordinate there should be negative 1/2. I'm going to keep this thing going, all right? I'm going to go all the way around the circle. I'm not going to do this for each trig function. I just really want us to, for this first one, understand what's going on. 5 pi over 4. And that should be negative root 2 over 2. The next one,
3 pi over...
4 pi over 3. So it's 8 pi over 6, but we're reducing it. So 4 pi over 3. And that should be negative root 3 over 2. So the book has a unit circle in it, all right? And no? It does not? Is that what you're saying, or no? Oh. No, it should have one. But I'll provide you one. All right? I'll provide you one. Yeah, you can get them in the math lab. All right, everybody is allowed to have a unit circle. I would encourage you to get one, all right? But I'll post one up on Canvas for you. In the days before Google, it was harder to find unit circles, but nowadays you can find them. Where are we at? 4 pi over 3. Next one is going to be 3 pi over 2. So we're straight down now, aren't we? And this is going to be negative 1. We're now starting to walk into the fourth quadrant. So we are now at 5 pi over 3.
Yeah, you're in the fifth there.
10 pi over 6. Yeah, hold on. Not. See, sometimes I just have to march around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pi over 6, which reduces to be 5 pi over 3. So we are at 5 pi over 3. And the y-coordinate there? Negative. If we're down here, I'm further down here than I am over. So negative root 3 over 2. Next one. 7 pi over 4. And this should be negative root 2 over 2. And then there's one more before we get back to home. 11 pi over 6. Which is negative 1/2. And then when we get to 2 pi, we're back at 0, right? And then it's just going to repeat itself. So I have two questions for you. What's the domain? And what's the range? What does it appear to be? What can I plug in? These were all numbers, weren't they? Okay, I'm using the common angles because I can give you answers quickly, well, relatively quick. But I could have picked any angle, right? Any positive angle. Could I have picked a negative angle?
No. Yeah.
Yeah, we can go backwards, can't we? Like positive angles go like this, but negative angles just go the other way, right? So I can do negative angles also.
So the domain's all.
So all real numbers again. Agree? So I'm going to say t is an element of negative infinity to infinity. I can plug any number into a sine function and it will spit out an answer. Yes? You can just write negative infinity to infinity. The reason I like to put t, or this little thing here, is because this lets me know that you understand that the domain variable is t, and that t has to come from here. If you just put this, then that doesn't necessarily indicate that you understand what the domain variable is, what we call the independent variable. All right, what about the range? The outputs, right? So I'm going to say this. I'm going to say instead of putting y, I'm going to put f of t must be an element of. So my outputs, right, must be an element of what? 0 to infinity? Negative 1 to 1? What do you all think? If we're on the unit circle and the sine function spits out the y coordinate, what's the largest y coordinate I can have on that unit circle? 1. What's the smallest? Negative 1. Not smallest. What's the most? Lowest one. Well, smallest would work. Yeah, in math, you have to be careful with smallest. Because when you say a number is smaller than the other, it means to the left on the number line. But you can also mean small to mean absolute value, magnitude small, like 0.0001 is small, right? Y'all get what I'm saying? Let's see if you get what I'm saying. Which one of those numbers is smaller? Negative 5 is smaller in terms of number line. It's to the left. But which one of those has a smaller absolute value or magnitude? It would be 0.001. So we have to be a little careful with our language when we say small line here. So the largest value would be 1, and the smallest in terms of number line would be negative 1. Agree? I'm going to do it this way. Negative 1 with a bracket to 1. Close bracket. That's the way I'm going to put it. Now, that's great. That means our sine function, when we draw it, cannot go above 1, can't go below negative 1, right? It can actually achieve 1, though. Like, it can make it to 1. It can make it to negative 1, but nowhere outside of that. How about cosine? Could we do a similar table for cosine?
Yep.
It would just give us all the x coordinates instead of y coordinates. I don't feel like doing a table for cosine, but let's talk about the domain and range, because I think maybe you get it now. For cosine, if it's just giving me the x coordinates instead of the y coordinates, then the domain, we should still be able to get everything, right? We should still be able to plug any number in because that's our angle. The outputs for cosine are the x values, and on a unit circle, you're always stuck between negative 1 and 1 also, right? Your x values will always have to be between here and here. So your domain is the same and the range is the same. Y'all agree with that? How about tangent? Here's where things start getting a little interesting. Let's try and remember the definition of tangent. It was y over x, wasn't it? Yeah. Okay. Where are you going to start to have problems? Where does the tangent function have problems? Anytime x is 0, right? Anytime x is 0 means that anytime you try and get 90 or 270 or any angle that lands there, right? Because I could land here by doing 90, but I could also go around 360 and then add another 90, right? 450 would land me there also. So it's not just 90 and 270. It's actually an infinite number of angles that I can't plug in. Do you all agree? That's a problem, domain-wise, right? Y'all see it or not?
Yeah.
Okay. So how in the world am I going to say that then? Ooh.
You're going to have some kind of
Yeah, we basically want to say, look, your t can be anything except an angle that lands you here or here, right? Yeah, let me try this. How about I say for this one, the domain is t cannot be. Instead of me telling you what it can be, let me tell you what it cannot be. It cannot be pi over 2. Agreed? Now, it can't be 3 pi over 2 either. It can't be, what's another one? Yep, this is pi over 2, 2 pi over 2, 3 pi over 2. So it can't be pi over 2, 3 pi over 2. Can't be, what the hell did I just say? Sorry. This is pi over 2. Can't be that. 2 pi over 2. 3 pi over 2 can't be. 4 pi over 2 can't be. 5 pi over 2. 7 pi over 2. So it can't be 5 pi over 2.
odd integer multiples of pi.
7 pi over 2, right? First, I'm trying to get you to see the pattern. Do you all agree with this?
Yes.
Now, this is great, but we need a better way of saying this. So here's how we say it.
It's the odds.
Yep, we can say odd, but I'm going to do, I guess, almost an even better way. All right, so watch. We all agree that pi over 2 is no go, right? Can you get from that point to this point by adding something? Pi, right? 180? So I can't be pi over 2, but it can't be pi over 2 plus a pi. Now, can you get from this back to here? Add another pi, right? Can you get from here back to here? Add another pi, right? And then back to here, another pi. Or I could have started here, subtract pi over 2, then subtract pi, subtract pi, subtract pi. So let me write something else down here and see if it makes sense to you. I'm going to say t cannot be pi over 2 plus, I'm not going to use minus, I'm going to put, let me see if the book uses k or n. Different books use different things. Oh, they're not even ready for that. That's okay. I'll use n. N pi. Where here, n is any integer. Now, what is an integer? You need to know what an integer is for this to work.
Exactly.
An integer are the numbers 0, 1, 2, forever, and the other direction, -1, -2, forever that way. Integers are all the whole numbers, both the positive and the negative, and including 0. So this is saying, look, I cannot stress to you enough how important it is for you to understand this, because we will need this later when what we're going to do is solve trig equations, and we're going to need to use this sort of notation to get what we call our general solutions. So back up. I start here and I say, hey, look, that angle's no good. But I also recognize that the angle that's directly across from it is no good. And then to get back here, directly across, no good. And if I keep just jumping directly across, back and forth, if I keep on just adding or subtracting pi, I'm going to still be at one of those, right? But I need to figure out, where do I start from? Well, I have to start from pi over 2, right? I have to start aiming here, and then from there add multiples of pi, or subtract multiples of pi. And I'm going to land on one of these two spots all the time, right? Yes? Okay. So this is our general answer for the domain. Everything except pi over 2 plus n pi. Now, someone had said odd, right? Okay, so I'm going to do something here. I'm going to get a common denominator for this. So everyone see that that's over 1? Common denominator would be 2, wouldn't it? Okay, so if I say t cannot be pi over 2 plus 2n pi over 2. Now I can put them together, and that would mean t, I'll leave it, t cannot be, what's pi plus 2n pi? Well, you can't put those together. It's 2n pi plus pi over 2. I know that looks strange, but that's what that is, right? I'll do one more thing on the top. I'm going to factor a pi out. So t cannot equal, I'm factoring out a pi on the top. See if you believe this. 2n plus 1 times pi. I factored it, but I pulled it out of the back instead of pulling it out front. Is that all right if I factor a pi out like that instead? Okay. Someone had said odd, right? 1, 3, 5, 7. You see that right there? 1, 3, 5, 7. If I say 2n plus 1, do you all agree that 2n is always an even number, right? And if I add 1 to it, that's always an odd number. This 2n plus 1 actually generates all the odd numbers. And that's how you can generate this sequence of numbers. You can see it right there better if you write it like that. You can't see it as well here. If you take Cal 2, you spend time doing what's called sequences in series, where you have to generate, a list of numbers like this, so you have to be able to take that and write it in a formula like that. So it's good to see it now anyway. All right, that was just the domain. What about the range of tangent? How about the outputs? This is tougher to figure out what's going on. What is the range, the outputs of tangent? So it's your y divided by your x, right? So let's just start here. What was tangent of 0? Tell me what tangent of 0 was. It was 0, wasn't it? Okay. Let's take an angle that's really, really small, okay? Really tiny angle there. Let's take the y-coordinate, which is really small, and divide it by the x-coordinate, which is big, right? What is a very small number divided by a very big number? It's less than 1. It's going to be small, isn't it? So tangent here, I'm just going to put here, tangent here is small. So it starts at 0, and then as you go, it's small, right? What happens when you get to 45 degrees?
They're almost here.
They're the same, aren't they? So what was tangent of 45 degrees?
Root 2 over 2 over root 2 over 2.
Which was 1, right? So when we get to here, tangent is 1, isn't it? Yeah? Remember, what I'm looking at here is what's coming out of the tangent function. What's coming out? We know 0 comes out, right? We know small numbers come out. We know that 1 comes out. But does anything bigger than 1 come out? Let's see. Let's take an angle that's really close to pi over 2. Remember, we can't get to pi over 2, can we? It's undefined there. What about that number right there? Tell me about the y-coordinate. It's going to be big, right? Tell me about the x-coordinate. It's going to be small. What happens when you take a large number and divide it by a small number? It gets bigger. How many of you need calculus 1? Most of you? This is important, all right? If I take a big number, and big is relative, but let's say I take the number 8 and I divide it by the number 0.01. That number is bigger than 8, right? If I take the number 8 and divide it by an even smaller number, right? Then that gets even bigger. Agreed? Big divided by small is big. So this right here would be big, wouldn't it? All right, let's move even closer. Okay, if I move even closer, what about that number? The y got just a little bit bigger and the x got a little bit smaller, which means that number should get even bigger. Can I get closer? Yes, I have an infinite number of angles in there. You can always get as close to pi over 2 as you want without getting there. So as I start to move over like this. I start at 0. As I start to move, the ratio starts to get huge, doesn't it? Y over x. And then when I get to pi over 2, it's undefined. What do you think that looks like? Think about college algebra. We had graphs. Here's a parabola, right?
Or no, it just disappears.
Disappears. But what is it doing as it's getting close to it? As it gets close to pi over 2, what's it doing? It's getting big. It's getting big and positive, right? Big and positive. What was that? We had that in college algebra, that you were going, you had a function, all of a sudden there was like, you couldn't be here because it was undefined. An asymptote. That's exactly right. So what's happening here is that this function, at 0, it's 0. And then as you start to plug in values, it starts to get bigger, gets to 1. And then as you get close to pi over 2, it starts to really get big. And the closer you get to pi over 2, the bigger and bigger it gets. So you get this picture. We're not ready to graph these. We're going to graph these next class. But this is basically what this graph looks like. At 0, it's 0. At pi over 4, which is halfway, we're up here at 1. But then as you start to get closer to pi over 2, this thing starts freaking out. You can't be at pi over 2, so the graph starts to take off to infinity. And you have what we call a vertical asymptote. That's what's going to happen with the tangent function. But I'm trying to get you to see it off the unit circle. Okay. So it looks like so far for range, because I've answered domain, right? For range, for tangent, I know it's 0, right? I know 0's in there. I know that I've got small positive numbers, and I know I keep getting bigger and bigger numbers, and they can get as big as I want them to get. So far it looks like 0 to infinity, right? Including 0. What about negatives? Can you get negative numbers? How about this angle right here? What's tangent of 3 pi over 4? Negative 1, right? What's tangent of pi? 0, right? What about right here? Try and give me this one right here. Is that going to be a small number or a big number? Tangent. You got your y coordinate, right? Which is a positive number, divided by your x coordinate, which is small, but it's negative, isn't it? Your x is negative here. So you got a big positive number over a small negative number. That should give you a big negative number. And what if I get closer? Bigger and negative, closer, bigger and negative. So what you're going to wind up getting is all the negative numbers too, to infinity. So your range, you get everything out of the tangent function. It spits everything out. If you want it to ever spit out negative 200, you can make it spit out negative 200. I'm trying to make a relationship between the functions and their graphs without actually showing them to you yet. We will graph them. All right. How are we doing here? Let's talk about the reciprocal functions. How about cosecant theta, or cosecant t? That's the reciprocal of sine, isn't it? Yeah. All right. Let's see if we might be able to figure out what's going on here. Things are going to start to get a little complicated, more complicated. This is the same as 1 over sine of t, right? We could do a t table and start filling in, but I'm not going to do that. I want you to start by telling me where we're going to have problems, because I want to know the domain and range of this right now. Where am I going to have problems?
180.
Whenever that sine of t is 0, right? When this is 0, this thing's undefined. So you're really going to look at this unit circle, and in your mind you're saying, I want to know when this is 0, right? Which means when is the y coordinate 0? And that's going to happen here and here, right? Those 2 points, your y coordinate is 0. Now can you tell me then what your t can't be? Pi plus what? N pi. Perfect. Now, you could have also done 0 plus n pi. Either one of those would have worked. In fact, there's an infinite number of them. But let's see if the first one makes sense. So what you were thinking was, OK, I'm going to start out at pi, right? I can't have that. And then I need to get back to the other one. And to get back to the other one, I just need to add another pi. And then to get back there, just another pi. And then another pi. And then another pi. And so I should just start at pi and then add any multiple of pi. I don't want those. Not equal. I looked at it this way. Start at 0 and then just add pi's. And you're going to get the same thing, right? So either one of these works. The reason I like this one is because you don't need the 0. You can just put n pi. So t cannot be n pi. Any multiple of pi. So 0 pi, 1 pi, 2 pi, 3 pi, 4 pi. Throw all those out. Now, something more challenging. The range. Yeah, this one's harder. Let's see how y'all do with this. Do you remember what you told me sine of t had to be between? What did you tell me sine of t had to be between? The output.
Negative pi.
Negative 1 and 1, right? That's the range of sine. So that means that this denominator, the biggest it can be is 1, right? The smallest it can be is negative 1. So do you agree then that negative 1 and 1 come out of this? Because if I have a 1 down here, it's 1 up there. 1 over 1 is 1. But I also get negative 1 to come out. Can I get 0 out of this? Can 0 come out of this? No? Why not? I'm not saying 0 down here. I'm saying, can this whole fraction give me 0 ever? Why not? Why can't 1 over sine t ever give me 0? Why can't this happen?
Because 1 divided by anything can't give you 0.
1 divided by anything can't be 0. Now, this is one of those points, again, that algebraically you kind of miss out on. Look, if I give you a fraction and I tell you it's equal to 0, right? Fraction equal to 0. What you can tell me from this is that a can't be, or a is 0. A is 0. The only way that this can be true is if this is true. And the reason why is because I can always multiply both sides by b, and then it would reduce to this equation. So let me say this in words. The only way a fraction can be 0 is if the numerator is 0. The only way a fraction can be 0 is if the numerator is 0. The only way this fraction can be 0 is if the numerator is 0. This numerator can't be 0, it's 1. So it's impossible for us to get 0 out of this. So we can get negative 1 and 1 out of it, but we can't get 0. This one's going to be a little harder for me to do. Let's leave this as an open question. I think, because I know I can show it to you in a way that it's going to make a lot more sense once you see the graph of sine, then that will be easier for us to understand. But for now, we'll just say, range is kind of tough here. What about for secant? Secant, we're going to still have a problem with range. But let's talk about domain. What's the domain of the secant function? So do you want to tell me what it can't be? If it's 1 over cosine t, that's what secant means, right? Then you need to make sure that that cosine's never 0. So you better be sure that you're not here and here, right? Pi over 2 plus n pi. Exactly the same as the tangent, right? Same problem that tangent had. T cannot be pi over 2 plus n pi. One more. What about f of t is cotangent t? This is the same as, let's do it this way. Cotangent's the reciprocal of tangent, isn't it? But it's also cosine over sine. So I'm going to put cosine t over sine t. And if you write it that way, it's easy for us, I think, to see that the problem is going to be caused when sine is 0. And where does that happen? Those 2 points, right? Sine is your y-coordinate, and at those 2 points, your y-coordinate is 0. So the domain here is that t cannot be 0 plus n pi, so I'm going to put n pi. I still have like 3 minutes. Some important properties that we were just talking about domain and range there. But here are some important properties with sine and cosine. I know we're at the end of the class. I know we're at the end of the week. But these last 3 minutes are going to be kind of important. All right. Even and odd functions. Okay, even functions. A function is said to be even if f of x equals f of negative x. A function is said to be odd if negative f of x equals f of negative x. Okay, these are definitions from college algebra. In layman's terms, it means this. A function is even if plugging in a positive number is the same as plugging in a negative number. It doesn't matter if you plug in -2 or +2, it gives you the same answer. This says that plugging in the negative and the positive of the same number don't give you exactly the same thing. They're just off by a sign. That's the difference between even and odd. So let's talk about cosine. Cosine of t. Is that even or odd? So I'm asking you, is this true or not? So the left side of that equation says, give me what coordinate? Cosine t means give me the x coordinate, right? So this side means draw something, draw an angle t, right, off the unit circle, and then give me the x coordinate right there. This number right here, x. What does cosine of negative t mean? This is t, right? Where's negative t? Down, right? So negative t is down here. What's the relationship between these x coordinates? Aren't they the same? Because they're the same distance out. That means that this is this. That means that cosine is an even function. So cosine is even. Cosine of t is the same as cosine of negative t. So if someone says, what's cosine of 30 degrees? It's the same answer you get if you use negative 30 degrees. Now sine turns out to be odd. And let's see why that's true. Here's t. Let's look at sine as the y-coordinate, right? Negative t is down here. And now this y-coordinate is actually the opposite, isn't it? If this is positive y, this is negative y. So taking some value and plugging it into the function, oh, I didn't write it down. Sine of t, sine of negative t. This is not true, right? They're not exactly the same, but they're off by a sign, which means if I change that to negative, then it would be true. That's what it means to be odd. So cosine is even and sine is odd. And I think I'm out of time. Okay, do your best on the homework for this. I'm going to try, like I said, to get solutions up by tomorrow, but no promises. I've got a busy day tomorrow. Have a good weekend. We'll talk about the test on Tuesday. That's it, I guess, yeah. Do your homework. It's getting to that time of the semester where all the exams are coming up, right?